So in relation operation under the relation algebra, we have the different operation, 7 different operations. Those are the select operation, project operation, union, intersection, center difference, and Cartesian product. And next we have the rename. Okay, so I'm going to start the first operation for today's class, that is followed by the binary operation. As we know, the select operation, project operation, and rename operation are undercombined to the unary operation. But when talk about the unary operation, set intersection, set difference, and Cartesian product, at the time we require the two relations. So that's why we have the binary operations, we can say. So starting from the union operator. So from this slide, I'm going to start the union operator, and just let me know the screen is visible to all. You are able to see the slide. Any doubt? Yes.
No.
Okay. So union operator is denoted by the U symbol. Okay, you have to keep in mind the symbol. Please careful. You have to remember the all the symbols. So union operator is denoted by the U symbol, and it is used to select all the rows, that is tuple, from the two tables, and those are the relations I'm talking about. The okay. Here union operator can be understood by the two different terms like the relation R1. Suppose we have the relation R1 as a theoretically it is written here, and another relation here we have the R2. So how to interpret that is relation R1 union to the relation R2. So we have to use the symbol. So this is a mathematical notation into a relation algebra we can represent. And what we need to do if we have these two relation r1 and r2, so both have the same columns. You have to keep in mind the this word properly. And what does it mean by the both have the same columns means? Now anyone can give me what is mean by the both column must be same?
सर लाइक दोनों में एक ही मतलब प्राइमरी की जो होती है कनेक्ट करने के लिए वो होनी चाहिए
No,
या फिर
no.
जैसे वो फ्लाइट वाली में था पीछे एग्जांपल में लास्ट के दो के टेबल्स के कॉलम और ऊपर के दो वालों के सेम जा रहे थे
सर
uh,
प्राइमरी की के जगह जस्ट की सेम होनी चाहिए ना दोनों के लिए.
okay, actually, no, we are right now we can't see the key or this point. We can say the one attribute must be column, so on which we can make the relation, or can make the operation union operation perfectly. So this is the reason. If suppose we have the duplicate record, so we can set it necessary to key. There's no guarantee. There's no guarantee. So if it is okay, so we can say in general way the student told us in a very simple way the key attribute must be there, so we can justify the answer properly. So at least both table or both relation must have a common column or column attribute or field name, so on which we make the relation properly. Okay, this is my point, and according to you as well. So we can perform the union operations. Here you have to keep in mind the point properly. It is written over here as a notes purpose as well. The rows or tuples data represent in both the table will only appear once. What does it mean? If we have the tuple in R1 and R2 record, and if it is in both relation, then it will be written into the one into the resultant relations. Okay, so we can say, so resultant relation or resultant table will define that only the one tuple value. So this is the point you need to keep in mind, and it will discard the duplicacy. So while doing the relation, while performing the union operation, as you can see, no duplicate present after the union operations. And the syntax will be very simple syntax, as you can see over here: table name 1, union operator, and table name 2. So this is just idea about the union operator, and I will tell you more detail through the example, then you will understand this concept in simple way. Just let me know this simple operation what we need to do is clear to all. Union operation we have seen also into the set theory. If you remember set theory, so we have also do the same thing. So you have remember the such point, then you can keep in mind all those points. Same thing we will do over here. Okay, are you remembering the set theory? In the mathematical we have seen we need to pick only the common things, and we will write the only the one. Okay, this is the thing you are remembering. I think so. You are remembering such point.
Remembering,
यस
sir.
सर
Okay,
कॉमन
same thing.
काउंट करके बाकी जो नॉन कॉमन है उनको इंक्लूड तो करेंगे.
Okay, so no problem. Through the example, you can understand in simple way. Other student also not required to worry about the concept. Through the example, you can understand. So I need the answer from your side. I'm just sharing my table here. In the example, table one we have the course, and other table we have the student. And now course id, student name, student id. So how many columns we have? Three columns: course id, student name, and student id. In the student table we have the student id, student name, and student age. So what is the common thing we have over here? So you can say here we have the common thing, that is student id, and here we have the student id. So on this attribute we can make the operation. Okay, so that must be common thing. So we have the common attribute, or we can say the common column. Okay, so after performing the union operation, now what would be the result? Can anyone tell me? Just I need the answer from your side, because according to theoretically, if you are implementing such theory into the practical way, then you can understand. Now let me know what would be the answer. Yes, please tell me what would be the answer.
Sir, it will be a new table in which
Okay.
all entries will be there, but student name and student ID will be counted once only.
Okay, good.
So there will be four columns:
Okay, good, brilliant,
ID, student name, student ID, and student age.
super. Please go ahead. Yes, please
That,
tell me the entire answer.
sir, and sir, the new table will have only four columns:
Okay.
course ID, student name, student ID, and student age. So here, student name and student ID is only counted once because we have to neglect duplicacy,
Of
and
course.
age and student code and course ID is selected from the two different tables.
Okay, okay, no problem. I agree with this point. Now, keep in mind, student ID, that would be the 90 as 901. So this is the one tuple. Okay, I am writing tuple T1 for understanding purpose. How many rows we will have? Tuple T1. So here it is also matching, no issue. And 9 as 911. So this would be the my tuple 2. So this would be tuple 2. It is available. Yes, available, and it is also available. Next as 921. So this will be the tuple 3. So third record we will see. So here we have same, we have the third record. So fourth record we have. Okay, now tell me, will these two information count will be counted?
Yes,
Because
sir, counted. We can't neglect the information, sir. We have to neglect the duplicacy, not the information.
okay, good, this is the point. I'm we are getting the improper way. We will count the record or data, but we will not consider the duplicacy. So this is the point. So total number of the tuples will be the 6. The four are the common, there is no issue, but these will also be counted. So the total number of the tuple will be the 6. Of course we will have. So student name, if we want to print, then Ajit, Steve, Paul, and Lucy, Carl, and Rick to be printed without any detail. And the new relation will be formed by the four attributes. So let us have the example here. Okay, and how to write the query? So in relation algebra, so there is a simple answer: student name, student course. Okay, so course and student. So what does it mean? And what does it mean? From the student table we just want to print the student name, and from the course we want to print the student name. So after performing the table relation and student relation union operation between these two relation, we will get a new relation that is represented by the R, and it will contain total number of the attribute, that is a 4. So A1, A2, A3, and A4. And this A1 will contain the student ID, this A2 will contain the student name, and this A3 contain the course, maybe depend on the sequence. Okay, so course ID, and last we have the age. Okay, depend on the sequence of the attributes what you are making. So these four different columns will be the part of the new relation, that is R, and this R is coming from the performing the operation on the table T and S, and that is T and S means course and student. Okay, so I can change this T as a S. C, sorry. So this C table and S table, we are getting the relation, that is R. So mathematically I can represent my answer like this one, but after performing the certain operation, so I need to print the, or I need to execute any query student name. I need to print the student name from the course and perform the union operations. So we have the U symbol. And now what is the common thing we have over here? That is student name. So from student name, the information to be printed over here. So now how many student name to be printed? Six prints to be printed. Okay. Now tell me any doubt over here? Before seeing the answer, before looking for the answer, just let me know you have any doubt, then you can ask me. You can note down the important point which is written over here. As you can see, there are no duplicate names present to the output. Okay, this is the information which will come after the output, but I have written over here before. Okay, so what, how many record to be printed? Definitely the student name to be printed. Okay, so this will be the common part we have opted for the printing purpose. That is student name. Yes, tell me how many records to be printed, how many names to become, or how many names to be printed over here? Six.
Six.
Okay. So first will be the, okay. First will be the um, Aditya, Steve, Paul, Lucy, Carl, and Rick. Okay. And from this point, suppose we have the another name like XYZ, and that to be also counted over. But here we don't have, so definitely the only the these six names to be printed: Aditya, Carl, Paul, Lucy, Rick, and Steve. This is the point. So you can see over here, no duplicates name are present. If I if we are counting the duplicate records, so what happened at the time? Just see, Adit will be counted two times. Okay, and Steve also to be again two times. Adit will come three times. Steve will be two times, and Paul will come two times, and Lucy will come to two times as well. So number of records will be the six plus
Sir,
five. Yes, please tell me.
sir, in table one, Aditya, the record Aditya has two course IDs associated with it. So in
Okay,
the
okay.
union, wouldn't there be two?
Yeah, yes, union will be because we are performing the union operation on the student ID. So it doesn't mean there is no issue.
No, so then you just said that there will be only unique names, no repetitions. That is why. Because we would have to define two Adityas for the same for two different course IDs.
Okay, you are looking for the course ID. So this which course ID to be selected? Okay, you mean to say that over here?
What's up?
You mean to say that if we choose the S 901 of the student, that is Aditya, and his name is his age is 19, and his course ID will be the C101 and C104. So which course ID to be printed? You mean to say
Yeah.
that? Okay, so here only the first one will be printed. That is on the first come first serve basis.
Okay.
Okay,
So
but
then, sir, if we wanted to print both, how would we go about doing
okay,
that?
so at the time we have the Cartesian product operation. So at the time we have the Cartesian product, that is another operation we have. No problem. Because
Okay, sir.
in the union operation, there is a drawback. We are missing some information. On the first come first serve, we are choosing the first value only, and we have opted the course ID from the Aditya, that is C101, but the student also opted the another course as well. So here what happened, we are missing the some information. So to avoid the such thing, we have the Cartesian product operation. Okay, so I will come through, no issue, but this is a good point you have asked me. Thank you for asking this question. So I'm just coming on that point. This answer is clear to all. This union. Now tell me any doubt you have, then you can ask me. Just tell me. Any doubt you have, then you can ask me.
No, sir.
Okay. Uh, if I just update this query like this one, print on display, I'm not passing any condition. Okay, this is optional. Display. course like this one, course, um, uh, course union a student. I can do, there is no issue. I can do the course union student, and there's no condition. So what result to be printed? What result to be printed? There's no condition here. I'm just passing only the relations union. So course union student. Now what to be print? What would be printed over here? Yes, please tell me what would be printed.
So course ID and student ID, student name, student age.
Okay, so all, yes, all four attributes to be printed from the resultant, that is come over here. That is course ID, student name, and we have the last one is. So good, because we have not specified any conditions over here. So this is the point we need. Relational algebra is a totally mathematical, how you are interpreting, how you are putting the logic. It's good. Okay, now is it clear to all about the union operation? Now shall I move to
Yes,
ahead?
sir. Sir, can you please move to the previous PPT? Hello.
Yes,
Sir,
Disha.
can you show the previous PPT? Okay, okay, sir. Just a minute, sir.
Just now, what is the problem?
No, sir. Okay, I just want to see the tables. Okay, sir.
Okay, you are executing the output of this table into somewhere else, or you are seeing the result?
No, sir. I am noting down to my notebook.
Okay, thank you.
Okay, sir.
So, okay, just I'm moving to the another operation, but before moving to another operation, just let me know this union operation is clear to all. Yes, tell me, is it clear to all, or any doubt you have? Yes, say yes or no. So, okay, shall we move to the next slide or next operation?
Yes, sir.
Yes, sir, clear.
Okay, so here we have the next operation, that is the intersection operator. Just like the union, we can't do the any operation, and we can't pick the common thing. There's no issue from the common attribute, no issue, and a duplicacy we can avoid. But the intersection operator is just denoted by the reverse union, or just opposite of the u of symbol, we can say. So intersection operator is just denoted by the uh, opposite, we can say, u symbol, and it is used to select the common rows. Please keep in mind all the word, it will select the common rows from the two different relations. Okay, so suppose we have the two relation like r1 relation and r2 relation, then we can denote such relation like this one, and these relation will select the only the common tuples, common tuples, common tuples from the resultant, from the resultant, that is I am writing here the r is the resultant relation, from the resultant relation, so it will say the common tuples. So let's say we have the two relation r1 and r2, so then issue, so it is written over here. And note, you have to keep in mind the points, only those rows that are present in both table will appear in the result set. Okay, so syntax we can write over here, table name 1, table name 2. So here we have the course, suppose we have the course, and we have the student, so we can write like this answer. So here we have the same example, that is course relation and student relation. Now what would be the output? Now tell me the, again we have the same thing. So student ID will be the common factor, common attribute on which we will select the same thing. Okay, good. Now tell me what would be the answer?
सर कॉमन कॉमन लेंगे आईडीज में से जो
Yeah,
जैसे
I okay.
nine
So yeah,
one
just
वो
yeah,
इंक्लूड
Okay, so S901 is common here, it is matching here. Okay, so it is also matching here. Just I am just skipping all these points. And S91 is also over here. And S9212 will be here. S931 will be over here. And this will not be selected because it is not common into the both part. Yes, tell me how many rows to be printed?
Sir, 4.
4 or 5?
Sir, 4.
Okay, if 4 then why, if 5 then why?
Sir, since in table 1, that is
Yeah.
course, we have two common student ID, that is S901 and S901.
Okay.
And according to the intersection operator, we have to choose only the common things, common elements. So here
Com
we only choose one,
so
S901.
yes, good. So S901, what happened? We are choosing these two relation, these two tuples, and on the first come first serve, it will be selected first. So it will neglect or ignore the second time because it is already selected. Okay, it is already selected, and this S901 is already there is one tuple, so it will be selected. So I can say tuple one, that is record number one, record two, record three, and record four. These these rows or these tuple information to be printed without any problem. Okay, so now in the resultant relation we have the only four tuples. Now is it clear to all? Now tell me any doubt over here, then you can ask me, please let me know it is clear to all.
सर यूनियन में हम C104 भी इंक्लूड कर लेते हैं आदित्य का लेफ्ट हैंड साइड मेरा एकदम दिमाग से स्लिप हुआ
नहीं, यूनियन में ये था कि एक्चुअली यूनियन और इंटरसेक्शन क्या होता क्या है कि जब हम इस ऑपरेशन को परफॉर्म करते हैं तो जो पहला एंट्री मिल जाता है उसी को रख लेते हैं और दोबारा नहीं रखेंगे, क्योंकि क्या होगा कि S901 की आपको एंट्री दोबारा करनी हुई तो यूनियन में जब करेंगे तो वो डुप्लीकेसी आएगा तो वो उसको क्या करेगा, सेकंड वाले को रिमूव कर देगा, वो कंसिडर ही नहीं करेगा। इसलिए C104 count ही नहीं हुआ था। The student asked the same question because we have ignored, because we need to write the entry of the another time or next time to S904 and 901, and it will not be counted. Why? Because it shows the duplicacy. So same thing we have over here. If we try to do same thing here, then it will count as a duplicate. So we can't do into the resultant relations. This is the point. Okay, so now resultant relation, how many record to become? That is 4. So now tell me any doubt over here? Yes, please tell me, because I need to the another slide. I need to jump to the another slide. Any doubt you have?
No, sir.
No, sir.
Okay, so now tell me the what would be the output if I just print the name of the student from the course and student relation followed by the intersection operation. Okay, this is also known as the set intersection operation as well. So now tell me what would be the output?
So the common name from both.
So that's why I'm saying how many? Aditya, Steve, Paul, Paul, Lucy. Okay. These four to be printed. As I told you, the four tuples will be. So according to the four tuples, entire relation, we have this these four values. Now, any doubt over here? Just please tell me. Any doubt?
No, sir.
Okay. Okay. So next operation we have the set difference operations. Yes, please tell me. Have you remembered the such operation that is set difference operation? Yes. What is mean by the set difference operation? Just have you remembering any idea, or have you remembered any idea about the set difference operation? Are you remembering something here? Then please tell me.
Like if you're talking about R1 minus R2,
Okay.
Yes, sir. Like if we're talking about R1 minus R2, then the answer would be the elements of R1.
Okay, in simple way I can speak, but I need the answer from your side. That's why I'm saying.
Sir, suppose like we have two tables,
Okay.
and this table contains these tables have two common column, that is student name. So if we apply set the difference, then in table 1 and table 2, then what happens? The student's name that is in table 1 and that is not in table 2 will be print if we apply set difference, and if the student name is common in both the tables, then it is not display.
Here you are on the right track, but just let me clear the few important points before jumping or before seeing the answer in form of the exercise. Now, set difference is denoted by the minus symbol. Okay, you can see, but you have to keep in mind that there are two relations, that is R1 and R2. So the information which is contained by the R1, okay, and the R2 relation which does not contain the information which is having by the R1. So you can write the point over here. We want to select all those tuples or rows that are present in the relation R1. So definitely in the relation R1, some information will be yes, no issue, but not present into the R2. So we need to see what are the various tuples which are not present into the R1. So those will be discarded, and this can be done by the set difference operation, that is R1 minus R2. This is a mathematical theoretical we can see. So there is no issue over here, we can see. Now, any doubt over here? What do you mean by the set difference? The information which is contained by the R1, but the information which is followed by the R2, that should not be matched to the R1. Okay, so the information which is contained by the R1 but which is not contained by the R2, so we will discard such information. So the result information will be like from this statement. Now we have to keep in mind. Now, is it clear to all?
Yes, sir.
Okay, so here I have the query to all the student. If I am doing R1 union R2, or if I'm doing R2 union R1, the result will be same or difference? The result will be same or different?
Same, sir.
Same, sir.
Should be same, sir.
Good, good. So if I'm doing the R1 intersection R2, or if I'm doing R2 intersection R1, the result will be same or different?
Same, sir.
Okay, so from
Same.
the good, from the
Same, sir.
union operation and intersection operation, it is found that we are changing or swapping the position of the both relations, so resultant relation will not be changed. But in this case, what happened if we're doing something like this one, R2 minus R1, the resultant relation will be different, because what happened, this will be having the own meaning. So the information is showing that the R2 relation which contains some information but not present into the R1. So there these two values R2 minus R1 can't be same, not same. Okay, so this is the point we need to keep in mind while solving any problem into the coming days or any time whenever we are looking for the relation algebra followed by the set difference. So this is the point. So R1 minus R2 and R2 minus R2 R1 can't be same, but in the operation it will be same, that there is no issue. Now this point is clear to all,
Yes, sir.
because this is the most important point we need to understand. Okay, so same example we have over here. First we have the table 1, so this would be our relation R1, and this would be our relation R2. Okay, so if you want to the in set difference, so we can say R1 minus R2. So what I mean to say is, course, the information which contained by the course relation but does not contain by the student relation. So C minus S, the resultant would be like this one. And now tell me, what are the tuples or the information or data which is to be contained by the relation R? Just tell me. Yes, I need the answer from your side. So please tell me.
Sir,
Sir, course ID.
No, no, it does.
Sir,
Okay,
second tuple
yeah,
will be there.
yes. Can you repeat your answer?
So only second tuple in course, that will be C104 Aditya S901.
Okay, why?
Because we are taking the remaining elements that are in course, yeah, after the intersection of course and student.
Okay, can you leave it your answer in proper way, just step by step, so we can understand properly?
Yeah. The intersection between course and student are those four elements, right?
Yes.
C10, Aditya, Steve, first Aditya, Steve, Paul, and Lucy.
Yes.
And the remaining one will be C104 Aditya S901, the second tuple. So that will be remaining in R. That is what I assumed.
Okay, no problem. We are on the right track, which is so we can interpret this expression like into a different way. So the things we can say the yes, okay. So total number of the information we are coming getting, that is 4 echo. By this way, we are getting the total number of the tuple, that is 4 tuples. For total number of tuples, we are getting the 4 tuples. So I can writing over here 4 tuples, and that is to be opted by the C101, C106, 109, and 115. No issue. And what is the sense of C minus S? We can write this query like this one. Okay. So the information which is contained by the course, those this is the total number of the 5 tuples we have, and we need to remove total number of the 4 tuples which are opted or selected by the C intersection S, that is the 4 tuples, these one. So 4 minus 1. So which is the things which have been not selected by this operation, that is the 1. So we got the this relation. So this is another way to find the set difference. And same thing we are performing like the R2 minus R1 or into student minus course, or performing the relations between the student and course. Okay, which relation you are opting first, so your result will be different. So that's why I told you over here R1 minus R2 or R2 minus R1 can't be same. Okay, maybe some cases they may be same, but it will not be same. So this is the reason. So there only the one record to be stored into the relation R, that is C104 Aditya S901, and this is the best example for explaining the set difference. Yes. Now tell me, any doubt over here?
No, sir.
Okay. So we are doing the same thing. So we'll get the student name, that is Carl. Now why we are getting the Carl? Yes, I need
sir,
the answer.
R2 minus R1 we
Yes,
are.
good. Because I need to see your observation, because here we are choosing the first relation, that is student, and here we are choosing the second relation, that is course. But in the our example, what we have seen, we have chosen the first relation as a course and other relation is a student. So this is the reason. Okay, this is the reason. That's why we are getting the car. Okay. So this is the reason. And now it is clear to visible to all once again. Others Steve and Paul Lucy are the part of all this one, and Carl and Rick are not part of those one. So but S951 we are choosing this one. So this is no option. So there is Carl. So let's write the query to select those student names that are present as a student. but not present in the course table. So we have over here. So this is the reason. Okay, Carl and Rick. Okay, because these two students are not a part of the our relation. So Carl and Rick are not part of the this relation. Rest of the are the part of the relation. So Carl and Rick will be the two student name. Okay, so this would be the answer. Yes, the simple answer. Yes, tell me any doubt in the set reference operation? It is again simple. From which relation you are picking the first, that is most important. Okay, if I choose the course, if I'm just use the course minus student, then I got the answer Aditya only. Okay, if I choose the S minus C, so I got the these two different. So this is the point we need to keep in mind performing the set difference, from where we need to remove, from where we need to get the difference. Now tell me, is it clear to all, or everything is clear to all about the union, intersection, and set difference operation? Yes, please tell me. Do fast.
Yes, sir.
Yes,
Okay,
sir.
good.
Yes.
Okay, thank you. So here we have the last operations for the binary operation under the fundamental operation. So relational algebra, we have the fundamental operation, we have the binary unary. So from the binary operation, we have the last, that is a Cartesian product. Binary operation under the fundamental operation. Okay, I'm not talking about the additional operation. I'm talking about the fundamental operation of the relational algebra, of course, followed by the binary operation. So here the Cartesian product is denoted by the X symbol. And let's say we have the two relation, that is R1 and R2, and then we want to need the Cartesian product of these two relations. So we can denote such point by the simple way. And how we can write? You can you can you can choose in simple way. So R1 into R2, and it is very simple idea we can write. Okay, here before jumping to the example, I can help you to understand the something in simple way. Suppose tuples, and R2 relation contains the 5t means 5 tuple. Okay, in simple way I'm writing, and 6 tuple. Now after performing the Cartesian product, how many tuples will be? After performing the Cartesian product, then you can understand everything from here. Yes, please. Anyone who is just remembering any idea about the Cartesian product, so please tell me. We have the
Sir, 30.
five tuple 30, and why 30?
Sir, because we multiply each element of row second to the each element of row 1.
Yes, this is the point, because in the Cartesian product means, as the name says, a product, it means we have to multiply. So one tuple will multiply to the second relations, each and every tuples of the second relation. So we have the 5 tuples in the relation R1, and R2 contain the 6 tuples, and the total number of tuples will be the 30. So of course this is a simple answer. We can see over here the 30 tuples. Good, this is the answer. Now, and in this, duplicacy may occur, and we can have the multiple records in duplicacy issue. This is the main reason. Same thing we can over in the unit intersection, we are just removing, but here we can have, or we just want to duplicate record, so we have the Cartesian product. This is the important part. Here if we are doing the R2 into R1, so we will get the same answer, so there is no issue. But what we can say, the order, or the choosing the attribute sequence may change, but the total number of the record, total number of tuples will be the same as it R1 into the R2, or R2 into the R1. So this is the point we can say there's no issue. The issue we have in the set difference, because at that time which operation, which relation you are picking the first, but other than other different operation, like intersection, union, and Cartesian problem, there is no issue. Now tell me, theoretical part, it is clear to all? Just let me jump to the example. Yes, theoretical part is clear to all.
Yes, sir.
Okay, so I am just taking the example of these two tuple. That is the first. Sorry, these two relations. First one we have the R relation, and other one we have the S relation. And if you want to perform the Cartesian product between the R into S, okay. So how many tuples we have? 1, 2, 3. So it contains the three tuples, and it contains the 1, 2, 3, 3. So total number of the resultant relations will contain the 9 tuples. Okay, so I can say resultant tuple, it contains the 9. Now is it clear to all? Yes, tell me, is it clear to all?
Yes, sir.
And how many columns will contain by the resultant relation? Can I, because column A, column B, column X, and column Y, so it's showing that there's no common attribute we have here. We don't have a common attribute to column name or column field name. So how many columns name will be there? Yes, I need the answer. Please tell me. How many columns will be there? How many columns? Please tell me.
Sir, I think column will be 2 and rows will be 9.
Rows will be 9 if you are choosing the column 2 and you are choosing the rows 9. There is no issue. But what about how to maintain the column X and column Y information without picking or without choosing these column values?
Sir, we can store values in column A and B.
Okay, so A and B contained by the, okay, just I'm just taking simple example. First tuple I'm just picking A 100, and this should be mapped to the this one, and this one. These are first three tuples will be okay. So how to store this information? Double x double 99 y by 1 1 z 101 by these columns. So without these column, how to store this information into such a column? How you can manage? So there will be also the 4 columns: A, column B, column X, and column Y. Okay, this is the point.
Okay, sir.
Okay, so just let me use a different color, and this also contain the 4th record, this contain the 5th record, this will be the 6th record. Okay, and I am choosing the another color to elaborate my answer, and this will be 7th record, this will be the 8th record, and this will be the 9th record, and the columns will be the A, B, X, and Y. Okay, so this is my point.
Z,
Yes, just tell me what
Z,
no, there is no Z. There, how many columns we have? Column A, column B, column X, and column Y. Now see this is the result. If I'm doing
okay,
the R
okay.
into, if I'm doing the R into X, now you can see the result. There will be the 4 column: column A, column B, column X, and column Y. And now see, this is the AA, so X. Okay, this is for the B and the for the C. Now in the graphical way, I have already explained through the arrow symbols. Now here we have the resultant. Now if we are performing the S into R, our tuples will be the 9 without any doubt, but sequence will be the change. So what will be the sequence? X, Y, A,
A,
and B. Okay, so you have to think what we have asked and what have been asked in the examination. So use the appropriate concept. So this is a simple thing. Resultant relation may different, but total number of the tuples will be the same as it is 9. So this is the point we need to keep in mind. Okay, now is it clear to all about the Cartesian product? Is it clear to about the Cartesian product?